This is for Year 10 Methods Pathways. We're going to look at question 6 from exercise 3.3. A tablecloth has length 0.4 meters longer than its width. Okay, so that's actually a really important statement. We're going to use that later. Write an equation for the area of the tablecloth in terms of the length only. Okay, so with word problems, it's always important to draw a picture or diagram, just so we can set things up. Okay, so we want to write the equation of the tablecloth in length only. Okay, so the length is here for the length, but for the width, we know there's a relationship between the length and the width. We know that the width or the length is 4.4 meters longer than its width. So the width would be um, equivalent to the length, except it's zero 0.4 meters less. So if I were to write the width, it would be L minus 0.4. So the area would then be length times width. So it'll be L times L minus 0.4. And we've gotten everything in terms of L's, which is great. Okay, we don't want a W anywhere. So that's essentially what part A is asking us. Part B is asking us to plot the graph against length. Okay, so let's draw table values. So L area, and we're going to choose our values. Now we're going to be smart here. Why do I need to be smart? Because I know this is a real life situation, so we're not going to go into the negative values. So it would be wise to start at 0 perhaps. Okay. Now let's go 0, 1, 2, 3, 4, 5, 6. At 0, when I sub in L equals 0, A equals to 0. Now, before I even get started, I need to get an idea what the shape of the graph is. Because if I expand it, I get L squared minus 0.4 L. I know that the square term is positive, so I'm going to get a shape that looks like this. So it's going to be a positive parabola. Now, and I know my intercepts are going to be at 0 and at positive 0.4. Now, if I draw a rough graph, you're going to have your x-intercept at 0 and positive 0.4. And we know that it's going to be a smiley face, so it's going to look something like this. Now, can you see the dilemma? This is a worded problem, and this is the L-axis, okay, and this is the A-axis, the area axis. Now, the area can't be negative, so we have to discard that part, okay, because we don't want a graph where the area is negative, and we don't want where the length is negative as well. So our values really start at 0.4. Okay, so I'm just drawing 10 values just to get an idea of like how to draw the graph. But essentially, we want the graph basically where it's after or equal after 0.4. So if you were to draw the graph, meters squared and length in meters, we'll start at 0.4 and we'll go up like this. Okay, you can plot the points. So we'll plot some points just so that we're okay with plotting points on a graph. When L equals 1, that's 1 minus 0.4, that's 0.6. 0.6 times 1 is 0.6. 2, 2 minus 0.4 is 1.6. 1.6 times 2 is 3.2. 3, I'm going to use a calculator just for convenience. Well, we've got 3, we've got 7.8. So I did this one. 7.8, 4, I've got 14.4, 14.4, 5, 5, we've got 23, and 6. So I'll just sub in 6 here. See what we get. 33.6. 33.6. As you can see, these points are increasing. Okay, so that could be. So we're not going to plot 0, 0 because that's part of the graph we don't want. So we've got 1.6. So that's 1.6. That's 2 and 3.2. 3 and 7.8. Now, obviously, you've got graph paper, so you do a much better job. Mine's not to scale, unfortunately. And we've got 4 and 14.4. But as you can see, you get the idea. And then we've got 5 and 23. So you get the idea of like how this sort of works. So key consideration is make sure when you're plotting a graph, it's one, it's to scale. So my one's not to scale, so it's not that as good. It's not as good as your one. Two, make sure you only want the part of the graph that you want. That makes sense, okay? And in this case, it only makes sense because we've got areas and lengths, so it has to be positive on both sides. Okay? So hopefully it helps.